Now, to continue the conversation about information processing, we're going to go to the next step, and that's signal detection theory. And I said that slow because I keep having trouble saying detection, but signal detection theory. And what this is the idea that your ability to have an input signal, and because of whatever your experiences are or your view is, you make the proper decision. And so there's a couple of assumptions, right? So you make the decision based on what you perceive, but the perceptual process is what subjects you to the variability and error. And this perceptual process is the way that we internalize or we process that information that we perceive. So the strength of the perceptual information allows us to make a decision, and this decision or the strength of this perceptual information is along a continuum, right? So it's either really, really strong or very, very weak, or somewhere in between that continuum. But what we're going to do for this is we're going to look at a manufacturing plant and the production of glass, and think about drinking glasses and how these glasses are going to go through and they're produced, and there's individuals along the conveyor belt who are actually in charge of making sure that the glass is staying on or they pull the glass off. And so there's a couple things that we want to point out real quick here for you, and that's just the way that this looks, right? And so there's two things. Up here, there is the employee decision, and that comes down in the columns. And then in the rows, you have the actual truth. And so the actual truth is whether or not the glass is actually flawed or not flawed, right? So you have not flawed and flawed. And so that is actually what the glass is. And then the employee decision is, yes, it is flawed, or no, it is, other way, sorry, no, it is not flawed, or yes, the glass is flawed. And so again, when you look at this, as the glass comes down, the employee is going to say, I don't think the glass is flawed. And then as it comes down, if it's not flawed, then they let it go by, right? But if they say it's no flaw, the employee's decision, but it's actually flawed, they miss it. It goes through the process. Likewise, if they say yes, it is flawed, but it's not flawed, then we call that the false alarm, right? So they took something off that shouldn't have been taken off, and from a standpoint that cost people money, right? But if they say something was flawed and it was flawed, you have to hit, right? So if you look at it, these two corners are actually correct answers. These two corners are incorrect answers. So as we go through the process, just understand that we're comparing the employee's decision versus the actual truth. And the employee's decision is based off their perception of the signal, the input that they received, right? And so this is what a graph would look like. And so essentially on this side, this decision is acceptable. On this side, the decision is flawed, right? So if it was flawed, the employee took it off. If it was acceptable, the employee said, let it go by. But what we're going to talk about here is setting this thing called the criterion. And this is where the individual person, whoever is looking at it, is going to say, yeah, I need to take it off, or I need to let it go through, right? And so it's not the actual what's happening. It's not whether or not the glass was actually flawed or not, but it's the ability of this individual to say, you know, I think it's flawed, so I'm going to take it off. So what sets this criterion, right? And it's a process that we make in our individual systems that are based on a couple of different things. It's based on, and that's down here, based on our past experiences, whatever the instructions for the task were, and then our various biases about the task, right? And so we'll talk about a few of those. And if you look at each of these parabolas, this really talks about, so probability of a correct, rejection, probability of a miss, false alarm, and probability of a hit. And the criteria changes the shaded regions of all of these. So if I move the criterion this way, the shaded region of the probability of a false alarm increases. So that's how this goes, right? Is wherever I move this criterion left or right, is going to change the idea of whether or not I have a probability hit, a probability of false alarm, a miss, or probability of correct rejection. So I can move my criterion, and that adjusts the probability of each one of those four possibilities. And so we're going to talk about this criterion a little bit more. So real quick though, we want to make sure that we understand what a flaw and a miss is, right? And so flawed is when I rejected a flawed when it is not flawed, right? So, and then a miss is when I accepted something to go by that was flawed. And so if I rejected something, but it wasn't, then I made a mistake, and that was a flaw in perception or a flaw in my decision. And then a miss is actually when I allowed something to go by, but it was actually flawed. So the question becomes now, how with this criteria do I shift things? And what I want you to think about this is the idea of how our perception and how our own processes allow things to happen. So think for a second, how would perfection shift this criterion, right? So perfection is going to say what? I'm going to have a higher propensity to name things as being flawed as opposed to acceptable. The way it's currently drawn is I'm going to look at things as more acceptable than not. So if I was a perfectionist or my boss was a perfectionist, I would probably shift my criteria in this way. What that would increase is the probability of a false alarm. So if I was a perfectionist, my criterion would shift, and so I have a greater probability of saying something was flawed. Maybe it wasn't, right? But I would probably spend a little bit more attention to detail, as opposed to if I had a boss or a company that wanted to really maximize production of the classes, then I would either keep this criterion where it is, or maybe I'd even shift it a little bit more this way and have more things acceptable. And the probability of having a miss would increase at that point. And this would probably have a little bit of a negative side effect on my company, although I would have a lot of higher production of the classes going out. But the problem would be then people would argue, people would be upset because they had production of the classes. So there's this happy medium, and we can really play with the criterion. The criterion is going to be on what our goals are and what we're looking for, right? And so that goes back to that idea of it has to deal with the task, what our understanding of the task is, and what our previous experiences are. So these are all different kinds of components, right? And so what I want you to pay attention to is what happens with the shape of the parabolas, and then also what happens with the shaded areas. And so we talk about poor sensitivity, and this is a huge overlap of this area here. And so there's this poor distribution of the two individual components where the probability of capturing correctly flawed or capturing correctly okay and allowing it to go, but you have a lot more likelihood of either getting a miss or getting letting something go wrongly that was supposed to be corrected, right? And so then you have the enhanced signal, where the signal of the flawed signal is enhanced. Therefore, you have a less likelihood of missing something or getting it incorrectly and passing it wrongly, because you have more likelihood of getting correct. And the same thing here is if the sensitivity due to diminished variability of the internal signals. So if the signals are really, really high or really, really good, then it allows the signal to come through and be more correct.